All right, I want to look at a few concepts that tend to be stumbling blocks for some people. So the idea of position and displacement, velocity and average velocity. The difference here is position and velocity are instantaneous things. They occur at one point. Okay? Displacement and average velocity occur over a period of time, so they require a start and an end point. So they require 2 points. Okay? The way you can think about this is if I had a graph of, say, position versus time. Maybe this was my position graph. It looks something like this. Okay? So my position at any given time might be, say, let's say it starts out at 10 meters. Okay? So it starts out at 10 meters, and let's say this point up here is 12 meters. Okay? My position might be 10 meters, 12 meters, 0 meters. Those might be my positions. But my displacement from this point to this point would be positive 2 meters. Or my displacement from this point to this point would be negative 10 meters. So I need to think about using more than one point. The same thing holds true for velocity. Okay? I might say at this point here, the instantaneous velocity, the slope at that point is negative. But the average velocity between 0 seconds and that point is positive. So these numbers could be wildly different, but they could also be the same in certain circumstances. All right? So we're going to kind of go into this a little bit here. All right, so the first thing we need to know is how do we find some of these values? So position and velocity, what we need to do is we just need to use our position function and solve it. Velocity, same thing. We need a velocity function and solve it. In order to, if you had a position function, you need a velocity function, take a derivative. Okay, use that information that you're given and use either derivatives or integrals to get the function you need. Now, displacement and average velocity have more equations associated with them. So displacement you can find one of two ways. You can find the displacement by taking the final position minus the initial position. In this situation, you're going to need a position function. Okay? Or you can find the displacement by taking the definite integral from the start time to the end time of your velocity function with respect to time. So in this case, you will need a velocity function. So depending on which one you're given, okay, will depend on which equation or which method you'll use for solving for displacement. Average velocity, well, V average is equal to the displacement, whichever way you find it, divided by the time. Okay? And for those of you in calculus, if you think about finding the displacement this way, using the integral divided by the difference of the start and end points, that's your average equation, which is kind of cool. All right, so let's try this. Let's just do this with, I have a position function and I want to find a few different things. Okay? I want to find the position at 5 seconds. I want to find the velocity at 5 seconds. I wanted to find the displacement from 0 to 5 seconds and the average velocity from 0 to 5 seconds. All right. So here we go. Let's give it a try. So position, I need a position function. So all I need to do is plug time in here. And so I get 2 plus 18 times 5 minus 2 times 25. So I get 42. So my position function evaluated at 5 would give me 42 meters. If I want to find my velocity, I need a velocity function. To get from position to velocity, I need to take the derivative. So I get 18 minus 4t. And I can plug 5 in, and so I get 18 minus 20. So I get a velocity function at 5 of negative 2 meters per second. Okay. Now what about average velocity and displacement? Okay. So let's do displacement first. So which one should we use? Well, we can use either one. All right, so let's use the first one. So I already know my displacement at 5, so I know my initial. So delta x is going to be my displacement at 5 seconds minus my displacement at 0 seconds, because I'm going from 0 to 5. My displacement at 5 was 42 minus my displacement at 0. So if I plug 0 seconds in, I get 2. And so my displacement comes out to be 40 meters. The thing I see is if I have a displacement, students might just tell me what the position is. Are they going to be off? Yes. Are they going to be right sometimes? Yeah. If it starts at the origin, they're the same. And you started at 0 seconds. All right. The second way is to take the integral. So the integral from 0 to 5 of 18 minus 4t dt. And of course, you can just plug this in your calculator, and it will do that integral for you. So that's under math, function integral, and you will get 40 as well. Okay. And then the last one we're going to do is average velocity. So average velocity is displacement over time. So I just have to do 40 divided by my time interval. So V average, which is displacement over time. The displacement will give you 40 from 0 to 5 divided by the time of 5 seconds gives you 8 meters per second. So now notice my position and my displacement were different, and my velocity and average velocity were different. And that again is because we're not looking at a single point for average or displacement. We're looking over a time period. Hope that helps.